Everything we thought we knew about the universe just got turned upside down. Scientists discovered something so massive that it breaks the laws of physics as we understand them. And the scariest part? We've been staring at it this whole time without realizing what we were looking at. In 2025, astronomers made a discovery that has them questioning everything. They found cosmic structures so enormous they shouldn't exist according to our current understanding of how the universe works. The biggest one spans 1.3 billion light years and contains 200 quadrillion times the mass of our Sun. But here's what's really going to blow your mind. This discovery suggests we might be living inside something far bigger and more organized than we ever imagined. Picture this. You're an ant crawling around inside a massive skyscraper. From your perspective, you see walls, floors, maybe some furniture. But you have no idea you're actually inside this incredible architectural structure that stretches hundreds of feet above you. That's basically what just happened to humanity. Except, instead of a building, we discovered we're embedded in cosmic structures so vast they make our entire observable universe look like a tiny speck. The problem is simple, but terrifying. Every single assumption we've made about the universe being uniform and random at large scales just got shattered. We thought space was mostly empty with galaxies scattered around randomly. We were wrong, dead wrong. For decades, scientists have operated under something called the cosmological principle. This basically says that when you zoom out far enough, the universe should look pretty much the same everywhere. Like if you're looking at a beach from an airplane, up close you see individual grains of sand, but from high enough, it just looks like a smooth, uniform surface. But what astronomers discovered in 2025 is like looking at that beach and suddenly realizing the sand grains are actually arranged in massive organized patterns that stretch for thousands of miles. Patterns so big and so organized that they couldn't have formed naturally according to everything we know about physics. The discovery started with something called Quipu, named after those knotted string systems the Incas used for record keeping. This cosmic structure is a network of galaxy clusters connected by invisible threads of dark matter. When I say massive, I mean absolutely mind-bogglingly huge. We're talking 1.3 billion light years across. To put that in perspective, light from one end of this structure takes 1.3 billion years to reach the other end. That's longer than multicellular life has existed on Earth. But Quipu isn't alone. Scientists found multiple structures like this, and each one is breaking fundamental rules about how big things can get in space. There's the Rosette superstructure stretching 1.4 billion light years, the Big Ring spanning 1.3 billion light years in a nearly perfect circle, and the Hercules Corona Borealis Great Wall, which might be 50% larger than we previously thought, potentially reaching 15 billion light years in length. Think about that for a second. These structures are so big that even traveling at the speed of light, the fastest anything can go in the universe, it would take billions of years just to cross them. The Milky Way galaxy, which contains hundreds of billions of stars including our sun, is only about 100,000 light years across. These cosmic structures are tens of thousands of times bigger than our entire galaxy. And here's where it gets really weird. According to our best theories about how the universe formed and evolved, structures this large shouldn't exist. There is actually a theoretical limit called the cosmological horizon, which says structures can't be bigger than about 1.2 billion light years. Yet, here we are, finding structures that are 2, 3, even 10 times larger than this supposed maximum size. It's like discovering a building that's taller than the laws of physics say is possible. Something is seriously wrong with our understanding of reality. Let's dive deeper into what these discoveries actually mean and why they're so disturbing to everything we thought we knew about our place in the cosmos. First, let's talk about how these structures were even discovered. The scientists who found Quipu were using data from something called the Rosat X-ray satellite. This satellite can detect X-ray emissions from hot gas that sits between galaxy clusters. When galaxies come together in groups, they heat up the space around them, creating this hot gas that glows in X-rays. By mapping these X-ray emissions across the sky, researchers could see how galaxy clusters are connected to each other. They used a sophisticated computer algorithm called a friends of friends analysis, which basically looks for patterns in how galaxies are grouped together across vast distances. What they found was shocking. Instead of random scattered clusters, they discovered 5 massive superstructures within a relatively nearby region of space, between 425 to 815 million light-years from Earth. And the largest of these, Quipu, was so obvious once they knew how to look for it that one researcher said it was readily noticeable by eye in sky maps of galaxy clusters. Think about that. We've been looking at this thing for decades without realizing what we were seeing. It's like staring at a forest and only seeing individual trees. Then suddenly someone points out that the trees are arranged in the shape of a massive face that's miles across. Once you see it, you can't unsee it. But the discovery of these structures raises some deeply uncomfortable questions about our place in the universe. If these massive formations exist, what does that mean for everything else we think we know? Let's start with the most unsettling possibility. These structures aren't random. The Big Ring, for example, is described as nearly perfect in its circular shape. We're talking about a ring of galaxies that spans 1.3 billion light-years and maintains an almost perfect circular structure. The probability of this happening by chance is essentially 0. So if it's not random, what organized it? What force or process could create such geometric precision on a scale that dwarfs anything we previously thought possible? Some scientists are starting to consider possibilities that sound like science fiction. Maybe these are cosmic strings, theoretical one-dimensional defects in the fabric of space-time itself, left over from the very early universe. Or maybe they're evidence of what physicist Roger Penrose calls conformal cyclic cosmology, the idea that our universe is just one cycle in an endless series of cosmic eons, and these structures are somehow remnants or influences from previous universes. But there's an even more disturbing possibility that most scientists won't say out loud. What if these structures show signs of design or organization that we don't understand? What if they're not natural formations at all, but evidence of intelligence or engineering operating on scales we can't even comprehend? Now, I'm not saying aliens built giant cosmic structures. That's probably not what's happening here. But the level of organization and precision in these formations is forcing scientists to consider explanations that would have been laughed out of the room just a few years ago. Let's look at another aspect of this discovery that's equally mind-bending. These structures exist primarily as concentrations of dark matter, the mysterious invisible substance that makes up about 80% of all matter in the universe. We can't see dark matter directly, but we can detect its gravitational effects on the stuff we can see. What the recent discoveries show is that dark matter isn't randomly distributed throughout space. Instead, it forms this incredible web-like network of filaments that stretches across the entire observable universe. These filaments are like invisible highways that channel regular matter, the stuff that makes up stars and planets and us, into the patterns we observe. Think of it like this. Imagine you're in a completely dark room, but there's an invisible scaffold structure filling the entire room. You can't see the scaffold, but you can see tiny lights that are attached to it. By looking at how the lights are arranged, you can start to figure out the shape of the invisible structure they're attached to. That's essentially what astronomers have discovered. The galaxies and galaxy clusters we can see are like those tiny lights, and they're showing us the shape of an invisible cosmic web made of dark matter that fills all of space. But here's what's really unsettling about this cosmic web. We're not outside observers looking at it from a distance. We're embedded in it. Our galaxy, our solar system, our planet, we're all part of this vast invisible structure. We're like cells in a massive organism, completely unaware of the larger body we're part of. Recent research has shown that these large-scale structures don't just exist passively in the background. They actively influence everything around them. They affect how we measure the expansion rate of the universe. They cause distortions in the cosmic microwave background radiation left over from the Big Bang, and they create gravitational lensing effects that bend and distort our view of distant objects. In other words, we're not just embedded in this cosmic web, we're being controlled by it. The structure dictates where galaxies can form, how matter flows through space, and even affects our scientific measurements. We're not free agents floating through empty space. We're prisoners in an invisible cage that we're only just beginning to see. This realization is forcing astronomers to reconsider some of their most fundamental measurements and conclusions about the nature of reality. For example, when we measure how fast the universe is expanding, something called the Hubble constant, these massive structures introduce errors of several percent. That might not sound like much, but in cosmology, several percent can mean the difference between a universe that expands forever and one that eventually collapses back in on itself. The presence of these structures also affects something called the cosmic microwave background, which is like a baby picture of the universe taken when it was only 380,000 years old. This radiation fills all of space and gives us crucial information about the early universe. But if there were already large structures present when this radiation was emitted, it changes everything we think we know about how the universe evolved. And here's perhaps the most mind-bending part of all this. Some of these cosmic structures appear to have been in place much earlier in the universe's history than we thought possible. Indian astronomers recently discovered a cosmic web filament that dates back to when the universe was only 2.1 billion years old, just 15% of its current age. This ancient filament stretches 850,000 light years and contains 7 galaxies arranged in a perfectly linear formation. The chances of 7 galaxies randomly aligning in a straight line across such a vast distance is astronomically small. Yet there they are, like cosmic breadcrumbs showing us a path through space and time that we never knew existed. The discovery required hundreds of hours of observation time with the Very Large Telescope in Chile, one of the most advanced astronomical instruments on Earth. The filament is so tenuous that its density is 100 billion trillion times lower than our atmosphere. It's basically empty space with just slightly more matter than the space around it. Yet somehow this nearly invisible structure guided the formation of galaxies across almost 1 million light years of space. To detect this structure, scientists had to use a technique that's like trying to see spider webs by looking at the morning dew that collects on them. They couldn't see the dark matter filament directly, but they could detect the faint glow of hydrogen gas that flows along it. This gas is so sparse and dim that it's almost impossible to detect. But by using sophisticated instruments and extremely long exposure times, they managed to capture its ghostly light. What they found was shocking. The filament shows signs of being pristine, meaning it has a metallicity that's 10,000 times lower than our solar neighborhood. This suggests it's made of matter that dates back to the very early universe, before stars had time to create and spread heavier elements through space. In other words, we're looking at the original building materials of the cosmos, still arranged in the same patterns they formed over 11 billion years ago. It's like finding the original blueprints for a building that's been under construction for cosmic ages. But the implications go even deeper than that. If these structures were already in place so early in the universe's history, it means the cosmic web formed much faster than our current theories predict. The standard model of cosmology suggests that it should have taken much longer for such large, organized structures to develop. This is where things get really uncomfortable for scientists. The discovery suggests that either our understanding of how gravity works on cosmic scales is wrong, or there were forces at work in the early universe that we don't know about yet. Some researchers are starting to consider exotic possibilities. Maybe there are types of matter or energy that we haven't discovered yet. Maybe gravity works differently on the larger scales than we think. Maybe there are extra dimensions of space that affect how matter organizes itself. Or maybe, and this is the possibility that keeps cosmologists awake at night, maybe our entire understanding of the universe is fundamentally flawed. Maybe we're like ancient people who thought the Earth was flat, completely missing the true nature of the reality we live in. The more we discover about these cosmic structures, the more questions arise. For example, scientists recently found something called the Eridanus supervoid, a region of space that's 1.8 billion light-years across but contains less than 10% of the typical number of galaxies. It's like a massive bubble of near emptiness in the cosmic web. This supervoid is so large and so empty that it's affecting our observations of the cosmic microwave background radiation. There is a cold spot in this radiation that corresponds exactly to the location of the supervoid, suggesting that these massive structures can influence the fundamental properties of space itself. Think about what this means. We have regions of space that are so large and so empty that they create measurable effects on the radiation that fills the entire universe. It's like finding out that there are holes in reality itself, holes so big that they distort the very fabric of space-time around them. And then there's the question of what exists beyond these structures. If our observable universe contains structures that are 10 to 15 billion light-years across, and our observable universe is only about 93 billion light-years in diameter, then these structures represent a significant fraction of everything we can see. But what if they extend beyond the limits of our observation? What if these cosmic structures continue on scales that are even larger than our entire observable universe? We might be like bacteria living in a single cell, completely unaware that we're part of a vastly larger organism that extends far beyond anything we can detect. The detection methods themselves are pushing the boundaries of what's technologically possible. The Multi-Unit Spectroscopic Explorer, MUSE, at the Very Large Telescope can capture images with such high definition that astronomers can detect structures whose density is trillions of times lower than anything we experience on Earth. X-ray astronomy through satellites like ROSAT reveals the hot gas that traces the underlying dark matter structure, showing us the invisible skeleton around which all visible matter is organized. Gamma-ray burst mapping tracks the distribution of the most powerful explosions in the universe, revealing patterns that span billions of light-years. Each new observation technique reveals more layers of organization and structure. It's like getting better and better microscopes, only instead of seeing smaller things, we're seeing larger and larger patterns that were hidden from our view. Computer simulations like the Millennium simulation have tried to model how these structures should form based on our understanding of dark matter and gravity. The simulations do predict web-like structures, but they consistently underestimate the size and complexity of what we actually observe. It's as if reality is more organized, more structured, and more complex than our best theories suggest it should be. The universe appears to be more like a living organism than a random collection of matter and energy evolving according to simple physical laws. Recent gravitational lensing studies have revealed even more disturbing details about how these structures work. When light from distant galaxies passes through the gravitational field of these massive structures, it gets bent and distorted. By studying these distortions, astronomers can map the distribution of dark matter in 3 dimensions. What they found is that the dark matter doesn't just form random clumps and filaments. It appears to be organized in a hierarchical structure, with smaller filaments connecting to larger ones, which connect to even larger ones, and so on. It's like a fractal pattern that repeats at every scale we can observe. This fractal organization suggests that the same fundamental process that creates structure on small scales, the gravitational attraction between particles of dark matter, also operates on the largest scales we can observe. But the precision and regularity of the patterns we see are difficult to explain through gravity alone. The implications extend beyond astronomy and cosmology. If the universe is organized in such a precise hierarchical way, it raises fundamental questions about the nature of space, time, and matter itself. Are we seeing evidence of deeper organizing principles that we don't understand yet? Are there laws of physics that operate on cosmic scales that we haven't discovered? Some researchers are starting to explore connections between the large-scale structure of the universe and phenomena in quantum mechanics. There are strange similarities between the web-like patterns we see on cosmic scales and the networks that emerge in quantum field theory. Could it be that the same quantum processes that govern the behavior of subatomic particles also influence the organization of matter on the largest scales? If so, it would mean that the universe is far more interconnected and unified than we previously thought. But perhaps the most unsettling aspect of these discoveries is what they suggest about our position in the cosmic hierarchy. We used to think Earth was the center of the universe. Then we learned we're on a planet orbiting an ordinary star in an ordinary galaxy among billions of other galaxies scattered randomly through space. Now we're discovering that our galaxy is part of a structure that's organized on scales we can barely comprehend. We're not just floating through empty space. We're embedded in a cosmic web that may extend beyond the limits of our observation. And if these structures continue beyond what we can see, if they're part of an even larger organizational system, then our entire observable universe might be just one small part of something unimaginably vast and complex. The psychological impact of this realization is starting to hit home for many scientists. We've gone from thinking we live in a mostly empty universe with randomly scattered matter to discovering that we're embedded in structures so large and so organized that they challenge our basic understanding of reality. It's like discovering that what you thought was your house is actually just one room in a building so large that you can't even see its walls. And that building might be just one structure in a city so vast that its boundaries extend beyond your ability to detect them. The tools and techniques that led to these discoveries are continuing to improve. Future missions like the Theseus satellite will help determine whether structures like the Hercules Corona Borealis Great Wall are really single connected formations or just apparent alignments of smaller structures. The Euclid Space Telescope and ground-based surveys like the Vera Rubin Observatory will map cosmic structure with unprecedented detail, potentially revealing even larger formations. Each new survey reveals more layers of organization, more evidence that the universe is structured in ways we're only beginning to understand. But the more we learn, the more questions arise. If these structures exist, what maintains them? What prevents them from collapsing under their own gravity or dispersing due to the expansion of the universe? Are there forces or forms of energy that we haven't discovered yet? And what about the voids? the vast empty regions between these structures. Recent research suggests that these voids aren't really empty. They contain a sparse network of dark matter filaments that may be connected to the larger structures around them. It's possible that what we call empty space is actually filled with invisible structures that we can't detect with our current instruments. The universe might be far more densely packed with organized matter and energy than we realize. The discovery of these cosmic structures is also forcing us to reconsider our assumptions about the age and evolution of the universe. If large-scale structure formed earlier than we thought, it might mean that the universe itself is older than we estimate, or that processes in the early universe were very different from what our current theories predict. Some of the structures we're finding appear to show signs of organization that date back to when the universe was less than 2 billion years old. At that time, according to our current understanding, there shouldn't have been enough time for such large structures to form through gravitational collapse alone. This suggests that either the universe had a very different early history than we think, or there were additional forces at work that we don't understand. Some researchers are starting to explore the possibility that dark energy, the mysterious force that's accelerating the expansion of the universe, played a role in organizing these early structures. Others are looking at more exotic possibilities. Maybe the structures are evidence of cosmic inflation happening in a non-uniform way, creating regions of space that evolve differently from each other. Maybe they're signs of collisions between our universe and other universes in a larger multiverse. Or maybe they're evidence of physics that we haven't discovered yet. New forces, new types of matter, or new ways that space and time can be organized. But here's the truly mind-blowing realization that's starting to dawn on the scientific community. What if these discoveries aren't just about astronomy? What if they're revealing something fundamental about the nature of reality itself? Think about this for a moment. We've discovered that our universe contains structures so large and so organized that they shouldn't exist according to our current understanding of physics. These structures appear to control the flow of matter and energy across billions of light years of space. They influence our scientific measurements and observations. They may have been present since the very early universe, and we're embedded in them. We're not outside observers studying these structures from a safe distance. We're part of them. Every atom in our bodies, every photon of light we see, every measurement we make, it's all influenced by our position within this vast cosmic web. This means that everything we think we know about the universe is potentially compromised by our location within it. It's like trying to understand the layout of a city while you're trapped inside one building. You can see some of the nearby structures, but you have no way of knowing what the larger pattern looks like from the outside. The implications are staggering. What if the fundamental constants of physics, things like the strength of gravity or the speed of light, aren't actually constant at all, but vary depending on your position within these cosmic structures? What if the laws of physics themselves are different in different parts of the cosmic web? Recent theoretical work suggests that this might actually be the case. Some models predict that the properties of space and time could vary on the largest scales, influenced by the distribution of dark matter and dark energy in the cosmic web. If this is true, then every measurement we've ever made about the universe is only valid for our particular location within it. The expansion rate of the universe, the age of the cosmos, the density of matter and energy, all of these fundamental parameters might be different in other parts of the cosmic web. We might be living in what cosmologists call a local bubble, a region of space where the properties of the universe are different from the cosmic average. This would mean that our entire understanding of cosmology is based on a sample size of one, our particular corner of the cosmic web. The discovery of these massive structures is forcing scientists to confront an uncomfortable possibility. Maybe the universe isn't uniform and isotropic like we've assumed. Maybe it's more like a complex organism, with different regions having different properties and functions. If so, then our search for a theory of everything, a single set of laws that explains all of physics, might be fundamentally misguided. Maybe there isn't one universal set of laws. Maybe the laws of physics vary depending on where you are in the cosmic web and what structures surround you. This would completely revolutionize our understanding of science itself. Instead of looking for universal laws, we'd need to understand how the properties of space, time, and matter vary across the cosmic web. We'd need to map not just the distribution of galaxies and dark matter, but the distribution of the laws of physics themselves. And here's the most unsettling possibility of all. What if our position within the cosmic web isn't random? What if there's something special about our location that allows life to exist and intelligence to develop? Some researchers are starting to explore the possibility that life can only exist in certain regions of the cosmic web, regions where the density of matter, the strength of gravitational fields, and the properties of space and time fall within very narrow ranges. If this is true, then the cosmic web isn't just a random distribution of matter and energy. It's a complex system that creates different types of environments, only some of which are suitable for the development of complex structures like stars, planets, and life. We might be living in what cosmologists call a Goldilocks zone of the cosmic web, a region where conditions are just right for the existence of galaxies, solar systems, and life itself. Outside this zone, the universe might be too dense, too sparse, too chaotic, or too organized for complexity to arise. This would mean that our observations of the universe are heavily biased by our location within it. We see a universe that appears fine-tuned for life, not because the universe as a whole has these properties, but because we can only exist in regions where these properties hold. The philosophical implications are profound. Are we seeing the universe as it really is? Or are we seeing it through the lens of our particular location within the cosmic web? How much of what we consider to be fundamental physics is actually just local conditions in our corner of space? And if intelligence can only arise in certain regions of the cosmic web, what does that say about the distribution of life and consciousness in the universe? Are there other Goldilocks zones scattered throughout the cosmic web, each potentially harboring its own forms of life and intelligence? The recent discoveries suggest that the cosmic web is far more structured and organized than we previously thought. If this organization extends to the conditions necessary for life, then the universe might contain vast regions that are essentially dead zones, separated by smaller regions where complexity and life can flourish. We might be living on an island of habitability in an ocean of cosmic structures that are hostile to the development of life. This would explain why the universe appears fine-tuned for our existence, not because it was designed that way, but because we can only observe it from locations where fine-tuning exists. But there's another possibility that's even more mind-bending. What if the cosmic web isn't just passively providing the conditions for life? What if it's actively involved in the development and evolution of complexity and consciousness? Some researchers are starting to explore connections between the large-scale structure of the universe and the emergence of complex systems. There are intriguing parallels between the hierarchical organization of the cosmic web and the hierarchical organization of biological systems, neural networks, and even human societies. Could it be that the same principles that organize matter on cosmic scales also operate on biological and psychological scales? Could the cosmic web be providing a template or framework that influences how complexity and consciousness develop? If so, then we're not just embedded in the cosmic web physically, We're connected to it informationally and organizationally. Our brains, our societies, our technologies, they might all be reflections of the same organizing principles that structure the universe on its largest scales. This would mean that by studying the cosmic web, we're not just learning about astronomy and cosmology. We're learning about the fundamental principles that govern the organization of complexity throughout the universe. And here's the most staggering possibility of all. What if consciousness itself is not just a local phenomenon that emerged on Earth, but a fundamental property of the cosmic web? What if the same information processing capabilities that we associate with intelligence and awareness are present in the organization of matter and energy on cosmic scales? Recent work in theoretical physics has explored the possibility that the universe itself might be a vast information processing system. The interactions between particles, fields, and structures could be performing computations on scales that dwarf anything we can imagine. If this is true, then our discovery of the cosmic web might be more than just a scientific breakthrough. It might be our first glimpse of a form of intelligence or awareness that operates on scales beyond our comprehension. We might be like individual neurons in a vast cosmic brain, just beginning to understand the nature of the larger mind we're part of. Our thoughts, our discoveries, our scientific understanding, they might all be part of a larger cognitive process that encompasses the entire cosmic web. This is speculation, of course. But the discoveries we've made about the large-scale structure of the universe are so far beyond what our theories predicted that we need to be open to possibilities that would have seemed like science fiction just a few years ago. The universe is revealing itself to be far more organized, far more complex, and far more mysterious than we ever imagined. We're not just studying distant objects through telescopes, we're discovering the true nature of the reality we're embedded in. And the more we learn, the more we realize how little we actually understand. We're like children who have just learned to read, slowly deciphering the first few words of a vast cosmic library that extends beyond our ability to comprehend. The discovery of cosmic structures like Quipu, the Rosat superstructure, and the Big Ring has fundamentally changed our understanding of the universe we live in. These formations are so large and so organized that they violate our most basic assumptions about how reality works at the largest scales. We've learned that the universe isn't a collection of randomly scattered galaxies floating through empty space. Instead, it's organized into a vast web-like structure made primarily of dark matter, with visible matter arranged along invisible filaments that stretch across billions of light years. These structures appear to have been present much earlier in the universe's history than our theories predict. They influence our scientific measurements and observations. They may determine where life can exist and intelligence can develop. And we're not outside observers studying them. We're embedded within them. The implications extend far beyond astronomy. These discoveries are forcing us to reconsider our understanding of space, time, matter, and the fundamental laws of physics. They suggest that the universe might be more like a complex, hierarchically organized system than a random collection of particles following simple physical laws. We might be living in a particular region of this cosmic web where conditions are suitable for the development of complexity and consciousness. Other regions might have very different properties, making them unsuitable for life as we know it. The detection of these structures required pushing our technology to its limits. X-ray satellites, advanced telescopes, sophisticated computer algorithms, and hundreds of hours of observation time were necessary to reveal patterns that had been hidden in plain sight for decades. Future missions and surveys will continue to map the cosmic web with increasing precision, potentially revealing even larger structures and more complex patterns of organization. Each new discovery raises more questions about the nature of reality and our place within it. The psychological impact of these discoveries is still being processed by the scientific community. We've gone from thinking we live in a mostly empty universe to discovering that we're part of structures so vast and so organized that they challenge our fundamental understanding of existence itself. These cosmic structures represent the largest known objects in the universe. They contain more matter than billions of galaxies. They span distances so large that light takes billions of years to cross them. Yet, they appear to be organized with a precision that suggests underlying principles we don't yet understand. The dark matter that forms the backbone of these structures remains one of the greatest mysteries in science. We know it's there because of its gravitational effects, but we can't detect it directly. It outweighs normal matter by a factor of 5 to 1, yet it interacts with regular matter only through gravity. Recent computer simulations have tried to model how these structures form, but they consistently underestimate the size and complexity of what we actually observe. This suggests that our understanding of how gravity works on cosmic scales might be incomplete, or that there are additional forces at work that we haven't discovered yet. The discovery of cosmic voids, vast regions of near-empty space between the structures, has added another layer of mystery. These voids aren't truly empty, but contain sparse networks of dark matter filaments that may be connected to the larger structures around them. The implications for our understanding of the early universe are profound. If such large structures existed when the cosmos was only a few billion years old, it means either the universe is older than we think, or processes in the early universe were very different from what our current theories predict. Some of the structures show signs of geometric precision that are difficult to explain through random gravitational collapse. The Big Ring, with its nearly perfect circular shape spanning 1.3 billion light years, has a probability of forming by chance that's essentially zero. This is forcing scientists to consider explanations that would have been dismissed as speculation just a few years ago. Cosmic strings, colliding universes, non-uniform cosmic inflation, and even more exotic possibilities are now being seriously discussed in peer-reviewed research papers. The tools that enable these discoveries continue to improve. Future space telescopes and ground-based surveys will map cosmic structure with unprecedented detail, potentially revealing patterns and organizations that we can't even imagine yet. But perhaps the most important lesson from these discoveries is humility. We've been forced to confront the reality that our understanding of the universe is far more limited than we thought. We're embedded within structures so vast that we can barely comprehend them, influenced by forces we can't see and subject to organizing principles we're only beginning to discover. The universe has revealed itself to be far stranger, far more complex, and far more organized than our theories predicted. We're not the masters of cosmic understanding we thought we were. We're explorers who have just caught their first glimpse of a reality so vast and so intricate that it will take generations to even begin to understand it. These discoveries remind us that science is not about having all the answers. It's about asking better questions and remaining open to possibilities that challenge our preconceptions. The cosmic structures we've discovered are forcing us to ask questions about the nature of space, time, matter, and reality itself. We're living through a revolution in our understanding of the cosmos. Just as the discovery that Earth orbits the Sun fundamentally changed our perspective on our place in the universe, the discovery of these massive cosmic structures is changing our understanding of the reality we're embedded in. The universe is not the random, largely empty space we thought it was. It's a vast, organized, hierarchical system of structures within structures, extending from the smallest scales we can observe to the largest scales we can detect. And we're not outside observers, we're part of it. This realization is both humbling and exciting. Humbling because it shows us how much we don't know about the reality we live in. Exciting because it opens up entirely new areas of research and discovery. We're at the beginning of a new era in cosmology and astronomy. The discovery of these cosmic structures is just the first step in understanding a universe that's far more complex and mysterious than we ever imagined. The implications will ripple through every area of science, from particle physics to biology to psychology. If the universe is organized on principles we don't yet understand, then those same principles might influence the development of complexity and consciousness at every scale. We might be on the verge of discovering that we live in a universe that's not just larger than we thought, but more unified, more organized, and more mysterious than our wildest theories suggested. The cosmic structures we've discovered are like signposts pointing toward a deeper understanding of reality. They're telling us that the universe has secrets we haven't even begun to uncover. And the most exciting part is that we're just getting started. Every new telescope, every new survey, every new analysis technique reveals more layers of organization and structure. We're like archaeologists who have just uncovered the edge of a vast buried city, realizing that what we thought was the whole site is just the tiniest fraction of something unimaginably large. The universe has been waiting patiently for us to develop the tools and understanding necessary to see these structures. Now that we can see them, they're going to guide us toward discoveries that we can't even imagine yet. We're living in the cosmic web, embedded in structures that span billions of light years, influenced by forces we can't see, and subject to organizing principles that challenge our understanding of reality itself. But this is just the beginning. As our instruments become more sensitive and our surveys cover larger areas of the sky, we're likely to discover structures that are even larger and more complex than anything we've found so far. Each new discovery will force us to expand our conception of what's possible in the universe. The recent detection of ancient cosmic web filaments using cutting-edge techniques like the multi-unit spectroscopic explorer shows us that we're developing the tools necessary to probe deeper into these mysteries. We're learning to see structures that are so tenuous they're almost indistinguishable from empty space, yet so important that they guide the formation of galaxies across cosmic time. The gravitational lensing studies that reveal the three-dimensional structure of dark matter are showing us that the cosmic web is even more complex than we initially thought. It's not just a network of filaments connecting galaxy clusters. It's a hierarchical system where smaller filaments feed into larger ones in fractal patterns that repeat at every scale we can observe. This fractal organization suggests that the same physical processes that create structure on small scales also operate on the largest scales. But the precision and regularity of these patterns are pushing the limits of what we can explain through gravity alone. There may be additional organizing principles at work that we haven't discovered yet. The detection of massive cosmic voids like the Eridanus supervoid is revealing another layer of the cosmic web's complexity. These aren't just empty regions. They're connected to the surrounding structures in ways that affect the cosmic microwave background radiation and other fundamental properties of the universe. Recent theoretical work suggests that these voids might play an active role in cosmic evolution, channeling matter and energy between different regions of the cosmic web. They might be like the spaces between cells in a living organism, not empty, but serving important functions in the overall system. The implications for astrobiology are profound. If life can only exist in certain regions of the cosmic web where conditions are suitable for the formation of stars, planets, and complex chemistry, then the distribution of life in the universe might be far from random. There could be vast desert regions where life is impossible, separated by oases where complexity can flourish. This would mean that our search for extraterrestrial life needs to take the large-scale structure of the universe into account. We shouldn't just be looking for potentially habitable planets. We should be looking for planets in regions of the cosmic web where the conditions are right for the long-term stability of complex systems. The discovery that cosmic structures influence our fundamental measurements of the universe's properties has implications for every area of astronomy and cosmology. The expansion rate of the universe, the density of dark matter and dark energy, the age of the cosmos, all of these parameters might vary depending on your location within the cosmic web. This means that our understanding of cosmic evolution might be biased by our particular position in the universe. We might be seeing a local picture that doesn't represent the cosmic average. To truly understand the universe, we'll need to map how its properties vary across the cosmic web. The recent discovery of pristine cosmic filaments from the early universe is showing us that large-scale structure formed much earlier than we thought possible. These ancient structures are like fossils of the early cosmos, preserving information about conditions when the universe was young. By studying these primordial filaments, we can learn about the processes that shaped the early universe and set the stage for everything that came after. They're telling us a story about cosmic evolution that's far more complex and interesting than we previously imagined. The connection between quantum mechanics and large-scale structure is an area of active research that could revolutionize our understanding of physics. If the same principles that govern the behavior of subatomic particles also influence the organization of matter on cosmic scales, it would suggest a deep unity in the laws of nature that we're only beginning to glimpse. Some researchers are exploring the possibility that the cosmic web is performing computations on scales that dwarf anything we can imagine. The interactions between dark matter particles, the flow of matter along filaments, the formation and evolution of structures, all of these processes might be part of a vast information processing system. If this is true, then our discovery of the cosmic web might be our first encounter with a form of intelligence that operates on scales beyond our comprehension. We might be like individual neurons becoming aware of the larger brain they're part of. The psychological and philosophical implications of these discoveries are still being processed by the scientific community. The realization that we're embedded in structures so vast and so organized is forcing us to reconsider our place in the cosmic hierarchy. We used to think we were insignificant specks in a mostly empty universe. Now we're discovering that we're part of an intricate, organized system that extends across the largest scales we can observe. We're not alone in empty space. We're connected to everything else through invisible threads of dark matter that bind the cosmos together. This interconnectedness might extend beyond the physical realm. If consciousness and intelligence are emergent properties of complex systems, then the cosmic web might be giving rise to forms of awareness that we can't even imagine. The discovery of these cosmic structures is teaching us that the universe is far more mysterious and wonderful than we ever thought possible. We're living in a cosmos that's organized, structured, and potentially conscious on scales that challenge our ability to comprehend them. As we continue to explore and map the cosmic web, we're likely to encounter discoveries that will shake our understanding of reality even more profoundly than what we've already found. We're at the beginning of a journey into a universe that's stranger, more complex, and more beautiful than our wildest dreams. The cosmic structures we've discovered are windows into a deeper reality that we're only just beginning to see. They're showing us that the universe is not just larger than we thought, it's organized according to principles that we don't yet understand. Every new observation, every new survey, every new analysis technique is revealing more layers of this cosmic organization. We're like explorers who have climbed to the top of a mountain and suddenly realized that what they thought was the entire landscape is just the first valley in a vast mountain range that stretches to the horizon and beyond. The universe is revealing its secrets to us gradually, patiently waiting for our technology and understanding to catch up with its magnificent complexity. We're privileged to be living at a time when these discoveries are possible, when we can finally see the true architecture of the cosmos we're embedded in. The cosmic web is not just a collection of astronomical objects, it's the context within which everything exists. Every star that shines, every planet that forms, every molecule that comes together to create life, all of it happens within the framework of this vast invisible structure that we're only now learning to see. Understanding the cosmic web is not just about astronomy, it's about understanding our place in existence itself. We're part of something far greater than we ever imagined, connected to the deepest structures of reality through bonds we're only beginning to perceive. The journey of discovery that began with the detection of Quipu and the other massive cosmic structures is far from over. We're at the beginning of an era of cosmic cartography that will map the universe with unprecedented detail and reveal patterns and organizations that we can't even conceive of yet. Future generations of astronomers will have tools and techniques that we can barely imagine. They'll be able to probe deeper into the cosmic web, detect even more tenuous structures, and perhaps finally answer the fundamental questions about how and why the universe is organized the way it is. But even with our current limited understanding, we can already see that we're living in a universe that's far more structured, far more complex, and far more mysterious than we ever dared to imagine. The cosmic web is showing us that reality itself is organized according to principles that transcend anything we previously thought possible. We're embedded in a cosmic masterpiece, a work of architecture so vast and so intricate that it took us billions of years of evolution and thousands of years of scientific development just to catch our first glimpse of its true nature. And this is just the beginning. The universe has been waiting for us to develop the wisdom and technology necessary to understand our place within its grand design. Now that we've taken the first steps on this journey of cosmic discovery, there's no telling what wonders await us as we continue to explore the magnificent structure we call home. Hit subscribe to stay updated on the latest cosmic discoveries that are reshaping our understanding of reality.